Hi everyone, this video is for Thursday, December 17th. This is the second video that I've put together teaching you about lesson 10. So make sure you have your whiteboard and supplies ready. Make sure you're remembering your norms. Even though this week looks a little bit differently, try to make sure you're being responsible and trying your best, even though this is a little bit different with me being out. This is our problem of the day. Olympic National Park is 28 and 5/10 miles from Forks, Washington. It took the Pierce family 3/4 of an hour, or 7/500th hour, to drive there. What was their average speed in miles per hour? So let's make sense of the problem together. The problem is about going to a national park. We're trying to find out what the average speed was for this family in miles per hour. So how fast were they traveling on average? The important information is the distance they drove and how long it took them to drive that distance. So this is a division problem. If you remember from science, finding speed involves knowing the distance and the time. And so we have to divide the distance by the time to find out how fast they were going. So I'm going to walk you through the steps just because this is the first time we're dividing with decimals, and I want to give you some tips and instruction. So the first thing we're going to do is change our numbers to make them easier on our brain to get an estimate. So 28.5, we're making 30. 7/500ths, we make 1. So we're getting a speed of around 30 miles per hour, just to give us that ballpark of are we in the right vicinity of our answer. So this is from your instruction book, page 94. I'm going to make it a little bigger for us to look at. So remember when we were talking in multiplication of decimals, it's good to think of it with fractions first. We're going to start that same way today. So since the fraction bar itself means division, we can rewrite a division problem as a fraction to understand better how to divide by decimals. So notice both of these numbers have decimals in them. So we're going to rewrite them as a fraction. 28's on the top, 28.5, is on the top. 3/4 or 7/500ths is on the bottom. The problem with this is that there is a divisor that has a decimal in it. And we don't want to have a decimal in the divisor. We don't want to have a decimal in the denominator. So we want to try to change this or find an equivalent fraction or an equivalent division problem that doesn't have to deal with this bottom number being a decimal. So to get a whole number, we're going to multiply the 7/500ths by 100. When we do, the decimal place moves 2 places to the right. If we multiply, though, because it's fractions, the denominator by 100, we also have to do the same to the numerator. What you do to the bottom, you do to the top. That's not a new concept for us since our work with ratios. So here's what that looks like in fraction form. We're taking our fraction, multiplying it by 100 over 100, and getting an equivalent fraction of 2,850 over 75. That and our original problem are exactly the same. All we did is multiply it by a form of 1. 100 over 100 is 1. So that's why we can do a little decimal trick, which I'm going to now explain to you, which will involve the traditional division algorithm, that whole house symbol. So remember, the divisor, that second number, has 2 decimal point places in it. We don't want that. So we are going to move the decimal point 2 places to the right to get a whole number, which is the same as multiplying by 100 to the divisor. So we're going to multiply the divisor by 100. However, you have to do the same thing to the dividend. So whatever you do to the bottom of a fraction, you do to the top of a fraction. Well, same kind of deal. Whatever you do to the divisor, you have to do the same thing to the dividend in order to make it equal or equivalent. So that's what this looks like. So we have our original numbers, 28.5, being divided by 3/4. And you see these red arrows signifying that we are multiplying 75 hundredths by 100, and the decimal point is going to move 2 places to the right. But because this is moving 2 places to the right, we have to do the same thing to the dividend. And you can see that arrow moving 2 places to the right as well. And so now we have a new division problem, which is equivalent, but now our problem with having a divisor with the decimal is gone. And our decimal point is technically to the right of that number 2,850. And technically it's to the right of this 5 too, but normally we don't show that decimal. It is really important to make sure you're understanding that the decimal point is to the right of that decimal point when we move on and actually solve. And so let me just erase this guy and make this guy a little cleaner. Working on the computer is a little tricky. Okay, so now this is the actual division. And remember when I said, hey, you'll have a chance to practice division when we do division of decimals? Well, this is why. I'm actually going to get rid of this right away. Okay, so now it's just like we did a couple of lessons ago when we were dividing with whole numbers. And we can multiply 75 times 3 to get 225. We're subtracting and getting 60. We're going to bring that 0 down, and lo and behold, it works out that 8 times 75 is 600, so we have no remainder. So this one worked out, and we are getting an answer of 38 miles per hour, meaning they didn't travel very fast, but it was very close to our estimate, remember, of 30, and that makes sense and is reasonable as our answer. So in order to divide with decimals, to just sum up, we want to change the problem so that, and rewrite the problem so that there is no decimal in the divisor. And in order to do that, we multiply by powers of 10. And the decimal point moves over until it becomes a whole number. And whatever hopping you do to the divisor or multiplying that you do the same thing to the dividend. So I want us to practice that with this next problem. And there's no context, it's just straight numbers for us to get this idea. So you can pause and actually try this now that I've shown you the tips and tricks that dividing with decimals involves, and then I'll go over it in just a second. So pause and try this one on your whiteboard. So you did not have to do this, but I want to show you again why what we're doing works. We're using this idea and concept that division and fractions are the same. We can rewrite this as a fraction and multiply by 100 over 100 to get rid of the decimal in the denominator in this case, or really it's the divisor in this problem. So if you're writing and using the traditional house symbol to divide, the 45 and 9/10 goes inside, the 25 hundredths goes outside. And so now we need to do that decimal hopping trick. So I'm going to move my decimal point 2 places, and now it's sitting to the right of the 5, and now I have 25. 25 hundredths times 100 is 25, just like you saw up here in the fractions. Whatever I do to the bottom, whatever I do to the divisor, I do to the dividend. So I'm going to move this around the 9, but I got to go one more. So that's going to create the decimal point here. And what I have to do is add a 0. Sometimes that does occur. So now this is my new problem. Same as my fraction, 4,590 is being divided, just going to get this x out of the way, divided by 25. So the very important thing that you have to do in this case is to remember that the decimal point is at the end of this number. And I want you to first, when you actually divide, drag this decimal up and put it in the quotient. because sometimes it works out like 38 did, but sometimes it doesn't. We want to annex those zeros. Now, if you're a partial quotient person, I would suggest playing around with the traditional algorithm just because of this decimal piece. Sometimes I find that kids who use the partial quotient method struggle a little bit trying to find those decimal partial quotients. It gets a little trickier, but I'm going to show you the traditional algorithm here. And if you're using partial quotients and having difficulties, you might want to experiment with this method. So again, review from a couple of lessons ago, you have to make sure you are looking at the numbers inside as they are going to be larger than the divisor. So I cannot have any groups of 25 and 4, but I can with 45. I can get one group of 25. And so I'm going to subtract. I'm just going to do this really quick with my computer pen. I apologize for my my writing with my pen and my mouse. And thank you for that, Grace. So I have that 20. I'm going to bring down the 9 next. I'm just going to change my colors here. So I'm bringing down that 9, and it becomes 209. That's really close to 200. So I know that is going to be 8 groups of 25, which is 200. And 200 goes underneath, and we subtract, and we get a 9. Next step, I am going to use some red here. I'm going to bring down the 0, making it 90, and I know that that will be close to 3 groups without going over, which is 3 times 25 is 75. When I subtract, I do have to do some trading, and I am getting an answer of 15 below, and that is less than 25. So I could write this as a fraction, but since we're in decimal land this week, I am going to annex this 0 and add a 0 and bring it down to be 150 so that I can get a number that is to the 10th place, because lo and behold, 6 times 25 is, I'm just going to extend this a little bit, is 150, and I have no remainder after that. So sometimes it might be necessary to annex a 0 or 2 and get your actual answer in decimal form this week. So we have 183 and 6/10 as our answer. Hopefully you got that. If not, no worries. I have one more that I want you to try on your whiteboard. This one is a word problem taken from your instruction book, page 95. Here it is. At a craft fair, Emily made $52.50 selling paper flowers. If she sold the flowers for 75 cents each, how many paper flowers did she sell? So again, just like our original problem of the day with that national park, we do have 75 hundredths in this problem, but it's a different situation. So we are dividing because we want to know how many paper flowers she sold, and all we know is the price and each flower costs that she sold it for. So I want you to pause the video and try to divide this problem on your own first on your whiteboard, and then resume when you're ready for me to explain it. So just like before, I'm going to show you what's happening fraction-wise and then show you the algorithm of the traditional way to figure it out as well. So we're writing this as a fraction with our decimal in the denominator of 75 hundredths. That's our divisor. We don't want that decimal at all, so we are multiplying by 100 over 100, and those decimal points are moving 2 places to the right when we're doing that. So that's what's happening mathematically. And now we are going to be, whoops, I guess I should have covered that up, but that's okay. Hopefully you did the same thing and can just follow along. So in the traditional algorithm, the 75 hundredths is on the outside. I want that to be a whole number, 75. And so I'm going to move the decimal point over 2 places to the right. What I do to the divisor, I have to do to the dividend. So you can see that hop, hop. I want you to be showing this on your work papers or on your whiteboards. And I want you to not just do this in your head. You need to write down the original problem, move the decimal points, and then rewrite the problem as you see I've done below. So that's important. So the first thing you do before you start dividing is you put that decimal point at the end, because you never know if we're going to need to annex zeros or not, and that gets dragged straight up into the quotient. Now we just have to divide like we did with division with whole numbers. So 75 is bigger than 5 and bigger than 52. So I have to, if you like to X out your place values that don't get a number in the quotient, you can do that. And I'm looking for 75 being multiplied by something to get close to 525. And it just so happens, if you figured that out, that it is exactly 7. So yay, hooray. Woo, that 2 got away from me, sorry. So our 7 is going to be placed above the 5. And then we're going to subtract. Let me get rid of that blue line. And you are going to get, let me catch up to myself here, 525. And we subtract and get 0. However, do you see this 0 right here? You have to bring down this 0 that's sitting in the ones place. This is a very common mistake that I see students doing. That decimal point is making me realize that I need a number here. Okay, this 7 is sitting in the tens place. So since it's a 0, I can put my 0 here, and 0 times 75 is 0, and this is kind of moot. You don't have to show this, but it is important to recognize that you do need to add that 0 in the ones place. And so for this problem, we are getting the answer of how many paper flowers did she sell? She sold 70 of them. So hopefully you got 70. A couple of things to recap and remind you with is that you want to show that multiplication and moving of the decimal to the right, and what you're doing to the divisor, you're doing to the dividend as far as hopping and changing the decimal point, and you have to rewrite your problem below, making sure to remind yourself where that decimal is now in the dividend and dragging it up into the quotient. It happened to be that we did not need to annex any of these zeros, but sometimes you do. So that is your instruction for dividing decimals. I want you to try this. This is also on Pear Deck, so I do want you to use that as a way to submit your exit ticket. And it's dealing with money and savings. And we want to know how many days he had been saving. So we have 2 important numbers here. The 25 cents is every day what's being saved. So we wanted to have that as our divisor, and our 91.75 is our dividends, just so that you're setting that up correctly. When you're done with this exit ticket, make sure you are going on to your practice and problem solving page in Kami, and it's in Google Classroom. And remember, this division is tricky, so feel free to take pictures of your work and submit on Kami that way. Writing on the computer, I know, is tricky. I've been doing it for these videos, and it's tricky. So don't forget about your iReady minutes, and if you have questions, you can always write me that message on your work. I am going to be giving you that feedback on how you're doing, even though I am not here this week. So good luck with your practice, and we will practice dividing decimals more tomorrow. A quick note about tomorrow's video. I actually did Friday's video before these. I wasn't anticipating being out, so I made Friday's video first, and for some reason, my lovely little picture on the corner did not show up. So you won't see my face in the video tomorrow, but you will on Monday. And so I will see you next time. Thanks. Bye, everyone.